So now we're going to talk about our measures of variation, which, as I said, are something like measures of spread. And to understand this, we're going to start with a motivating example, where here we have two brands of cell phone battery that are tested in 6 trials, with results shown in the table below, where we want to determine which of them is more reliable. Well, we've got these two data sets, and you can maybe eyeball some things about one versus the other, but can't really tell just looking at that. You want to get a little bit better. So let's think about taking these and looking at them in terms of their means. Well, if we compute the means for each, we're going to take the sum of all of those things and divide by 6. We're going to treat it as a population just because, but in both cases, we get 14. Does that mean that these batteries are equally good? Does that mean that it doesn't matter which one you buy? Well, thinking about that data set, you kind of have to think not really. Because battery 2 is pretty consistent. Battery 1 does not look very consistent at all. And maybe you're a gambler and you say, well, I'll take a shot at 24-hour battery life if it means sometimes I get 4 hours. But me personally, I'd rather feel confident that I'm going to get 12 to 15 fairly consistently. I'd rather not have to worry about my phone dying randomly because I get a bad charge one day. But point is, the mean doesn't really tell us anything that we need to know here. It doesn't communicate the information that we need about comparing those two batteries because it gets to the same place when obviously that same place isn't a meaningful representation of the picture. So that's where we will talk about the measures of variation instead.